And then we can hit the green check mark, and that creates our rib at 16 millimeters. Now, the one thing about this face here that really doesn't look that good is that we've got this face and this face and this face. We've got these kind of extra faces here. So if you do want to get rid of those faces, I think the best way to do that is to use delete face. So I'm going to choose delete face here. And when I choose delete face, I can choose this little, it's almost like a little dingus there, a little extra geometry that I wasn't anticipating. So I'm going to delete those two little faces and I'm going to say heal, and I hit the green check mark, and oh yeah, that's what we wanted. Hey, what's up everybody, and welcome to today's Onshape step-by-step tutorial where we are going to design a plastic part with draft. This is a pretty cool part. It uses drafted angles on various features. It uses some ribs, some patterns. I think you're really going to enjoy this part. And if you are just getting into the world of plastic part design and injection mold design, I wanted to let you know that about maybe like 5 or 6 months ago, I posted some videos on the Onshape YouTube channel where we talk about things like plastic part design and like creating a tooling set, and even some specific tools you will use in plastic part design, like different types of draft that you can apply and how to work with surfacing to create your tooling set and things like that. So if you are getting into the world of plastic part design, this will be very helpful. Be sure to take a look down below at the links in the description to those other videos, and be sure to like this video, leave me a comment, and enjoy this step-by-step tutorial. So go ahead, jump into, it says click here to practice, jump into it, and all of you can attempt to model this. And now we are going to attempt to model this together using Onshape. So right now we're watching this episode of Model Monday Live. It's July 21st, and all the people over in the chat, you can see the chat over on the left, all those people are attempting to create this 3D CAD model, and now we are going to try to create it as well. Maybe we can beat some of these speedsters in the chat. If you haven't joined us for Model Monday Live in the past, be sure to join us for the next episode. And on this second half of the show here, we are going to be challenging the chat, challenging each other by doing a live solve using Onshape, and by solving this thing using the Too Tall Toby Practice Models app. So we're going to head on over to tootalltoby.com. We're going to sign up for a free account. We're going to click Access Full Library. And we're going to see here that up at the top of the library, this is a library of over 190 challenges. They can be sorted by the type of challenge that you're trying to do, whether you're trying to do a 3D printed part or a woodworking part or a sheet metal part. They can be sorted by the level of complexity here, tier 1, tier 2, tier 3, tier 4, tier 5. Can do all this cool sorting here. But what we're also able to do is we're able to participate in these featured challenge practice models up at the top of the screen. And right now, all the people who are watching Model Monday Live are trying to complete this challenge here. So I'm going to click here to practice, and we're going to see here that there's a lot of skills that are tested in this challenge: draft, patterns, revolve, ribs, slot tools, symmetry, thin walls. I got a feeling this is a part that's going to be plastic injection molded just from that list of skills there. So let's see here. Nobody's done this yet. I mean, we just released it about 30 seconds ago, so of course nobody's done yet. I'm going to say click here to begin and go. So the question here is, what is the mass of this part in XXX grams? And we're going to try to calculate that mass, and then we're going to enter it down here. And if we enter it correctly, we're going to earn a point. If we enter it incorrectly, it's going to say, no, your answer is incorrect. You need to keep trying. So we need to come up with the correct mass, and we need to come up with the correct material density. So we see down here in the title block that the material density is 1020 kilograms per cubic meter, and that is the material ABS, which I've already got in my Onshape custom library. So what I like to do is, even though the clock is running, before I get started, I like to kind of come up with a game plan of how I'm going to model this thing up. So I'm looking at this thing, I'm seeing that there's a lot of draft on this part. We see that there's 6-degree draft typical. So we've got this draft here on this sidewall, some draft here as well, some draft here in this kind of center hub area, some draft all the way down to the bottom here. It is kind of interesting. There's a section here that's got a note on it that says 10 millimeter straight section. So it's almost like the sidewall here. If we're looking at this thing in the isometric view, there's like a straight section there for some reason. Normally you wouldn't see that in injection molding, although, you know, depending on the geometry and depending on the material, sometimes you could get the ejector pins to push that part out, even if it had a flat wall there. But you run the risk of that maybe getting stuck in the mold. So normally you wouldn't have that. But in the case of this model, we can see that we do have a little section on the model that is truly vertical. It's kind of interesting there. All right, so now let's talk about the game plan. So I think in a model like this, what I'm going to do is I'm going to start out with a revolved shape. So with a revolve, what you would do is you would start out with maybe a construction line. So like a construction line coming up here through the middle, and then you would create the geometry that you're going to be revolving about that construction line. So I think what I'll probably do is draw a shape that looks something like this. If we were imagining this as a section view, I'll create a shape that looks something like this, and I'll leave that gap there for that center bore, and then I will revolve that about a center line, and that's going to give me kind of the main wheel shape. So if we're looking at this over here in the section view, that shape that I just drew is going to look something like this. It's going to come up here, over, down, at the angle. I'm going to include the draft angle there, over, up, at a draft angle, down here, and then we'll have this little straight section, and then we'll close that off. That's going to be my first sketch along with a little construction line here, and that way I can revolve that first sketch. I think the next feature that I'm going to try to tackle is going to be this rib shape. So we notice here that with these notes on the rib shape, we're starting out here 8 millimeters down from the middle of the part, 5 millimeters down here from the outside of the part. And it looks like that rib has some curvature to it. It looks like it's got a radius here of 220 millimeters. So it's kind of an interesting rib shape, kind of a curved rib shape. So I think what I'll do is I'll probably create that right here, right on the right plane, create that rib. And then I think I'm just going to bring it down with some straight geometry, just straight down into the model, and then I'll go back in afterwards and add some draft, because you can see here the rib draft begins from this face down here. Another little Toby note there. You wouldn't normally see that in an engineering drawing, but we're doing kind of education here. But instead what you would typically see is like this section view BB, where we're clearly seeing this is 16 millimeters at the bottom, and then we're seeing it's got 6 degrees per side of draft going up to the top. We can also see that there's a note here looking down on this thing from the top view. These ribs are 16 millimeters at the base. So a little bit tricky here if you've never done any injection mold design. This might be a little bit new to you, but basically we'll add some draft here using what's called neutral plane, and then we'll bring that up. This is kind of a cool feature because we're also going to be able to use what's called intersection curve, which is it's kind of like a cool thing that you can do when you're working in 3D CAD. All right, so that takes care of those features, and then I think the final feature we're going to need to create is going to be this slot shape. And once again, we do have some draft here on this slot shape. So we can see that we've got this dimension 40 at the bottom, 40 at the bottom here, and then we've got this 6 degrees of draft, 60 degrees of draft on that slot shape. And then if we come over here, we see that this note says 55, radius 55, so this radius 55 here at the rear wall. Radius 95 at the rear wall. And so that 55 and that 95 makes that 40 that we saw there in that side view. So I think what I'll do is I'll create that sketch on this back face, and then I'll probably just cut extrude it with draft. May as well just include the draft in that cut extrude. So a few different ways that we're going to be creating draft here. Draft during the revolve, draft in the rib with the neutral plane draft as its own feature, and then draft as part of the cut extrude. And then once we're done, we can just pattern that around 3 times, and we should be good to come up with the answer. So let's see if any of our if that comes in correct. Let's see if any of our speed demons in the chat are able to beat me. And I'm going to move this over to my second screen so that I can start creating a document here in Onshape. So I'm going to say create document, and we're going to call this 25-07-06 tri-wheel W draft, tri-wheel with draft. Now, the thing is, I'm going to be creating this here in the Onshape public space. And the nice thing about this is that if you're using Onshape either as a paid user or even if you're using the free version of Onshape, you can search this public space and you can search for this file name. And then you would be able to see my model with the history tree. And so the nice thing about that is even if you're not an Onshape user, if you get stuck with this model, it might be helpful just to kind of poke through the history tree, and it might help you get unstuck. So really nice feature there of Onshape, that ability to create that geometry and then have it shared out to the world, really. So I'm going to say create public document, and that way anybody who wants to can get in and search for that document. Jern in the chat says, definitely seems on upper end of tier 4. Lots of little details. Yeah, it was surprising to me how few features ended up in the tree. So, you know, the tier 4 is really the complexity more so than the difficulty. And the complexity is just based on the number of features. Difficulty is a little bit more subjective, right? Based on your experience. If you do injection mold all day, every day, then this probably won't be that difficult. But if this is your first time, you know, working with an injection molded part, you might get a little bit lost in the details for sure. All right, so now that we are in this model here in Onshape, I'm going to start out just by clicking on this icon up here. And what that icon up there is going to do is it's going to give me access to a menu. It's called a hamburger menu, and it's from the hamburger menu that I can choose my workspace units. And I just always like to do this. I like to look at the drawing, look at the title block. It says it's in MMGS. So I always like to make sure that my unit for length is in millimeters and my unit for mass is in grams. So those two both look like they're correct. Now let's get into our game plan here and start with our first sketch. And I think what I'll do is I'll go to the right plane to create this sketch. I don't know. I'm not really sure which plane I want this to be on. I mean, this is kind of like the front view, right? Should I sketch it on its side? This is always a question that is sometimes easier to answer when you know how the model is used. But I think what I'm going to do is I'm just going to make this my right plane like this. And I'm just going to sketch the whole thing on the right plane like that in kind of an upright position. I don't know if that's good or not. It depends on how this model's used in an assembly, but it should work fine. So right plane, I'm going to press the S key. I'm going to begin a sketch. I'm going to press the N key. Actually, before I get started here, let's bring up our keyboard cam. That way you guys can see all the keyboard shortcuts I'm using. So I click on the right plane, press the letter S, choose the sketch command, press the letter N. Now I'm in a new sketch on the right plane, and what N does is it rotates the view normal too, so it's a little easier to see. Now I'm going to press the S key again. I'm going to create a line here, single click the origin, move over. I'm going to press Q. That makes that for construction, and I'm just going to drop a line out here. Maybe I'll make this close to the 60 millimeter max height, just to give me like a little bit of a sense of proportion. Now I'm going to hit escape, and now I'm going to create some additional geometry using the line command. So single click the line command. I could click here on this point, move up, single click, let go of my mouse, and type 15 because that lower bore is 30 millimeters. Then I can come out this way the rest of the way. And again, I'm just kind of trying to establish a sense of proportion so that I'm not too far off with my kind of final results here. So this one I'm going to come up at 10 millimeters. So I'll move over here, 10, single click, let go, 10, enter. Then I'm going to kind of come up at an angle, move down this way, single click, let go of my mouse. I'm going to type in 10 because that upper ledge there is 10 millimeters. Move back down here at an angle. Now the base is also 10 millimeters, so I could hold my mouse over this point and then get a relationship there of vertical. And that way I don't have to add that extra dimension. Move my mouse down this way, move my mouse up like so. Move single click, move my mouse this way, single click, let go of my mouse. I can type in 10 again, enter, and then I can finish off by just coming down here to that original point. Single click, and boom, done. Now, personally, I think I would rather have a diameter here at the bottom, so I think I'm going to hit escape, single click, eliminate that dimension, maybe even eliminate that line. It's not really going to hurt me, but it's just kind of in the way. And then I could take this point and make them vertical, V. So that line there goes black. This line here, it's orange currently. You can see it's black, meaning it's fully constrained. And now I can go S key dimension, and I can create a dimension from this point to this line and then move across that line. And that lets us create what's called a doubled dimension in Onshape. Very useful in Onshape. So we're going to make that 30, enter. We're going to create a dimension here from this point to that line. Again, cross over that line for that doubled dimension. That's going to be 260, enter. We could create a dimension that goes from this line to this line. That dimension is going to be at a height of, what is the height to that location? Let's see here, 40, enter. And then a dimension from this line to this line. That's going to give us a height of 60, enter. And then the final dimensions that we're going to put in here are going to be our draft angles. So from this line to this line here, that's going to be a draft angle of 6. From this line to this line here, that's going to be 6 plus 6, so that gives us 12. So draft in both directions. Dimension here from this line to this line here, that's going to be 6. And then a dimension here from this line to this line, that is going to be 12. And for me personally, I think this is a great place to stop with that first sketch. So it gives us, all the key dimensions for that revolve. The sketch is starting to get a little cumbersome, and I don't really like it when my sketches get too complicated. So if you're watching this as a tutorial, maybe you want to just take a moment, pause the video, and get your sketch to look like this, and then you'll be ready to move into the next step and turn this thing into a revolve. So I think what I'm going to do next is I'm going to choose to revolve this thing. I see in the chat, Sebastian in the chat says, that one fried my brain. Yeah, this is definitely one it's got a lot of cool little details. So I'm glad to hear that. I mean, I'm sorry to hear that your brain got fried, but I'm glad to hear that you like these kinds of challenges because these are the fun ones. Remember, the website's supposed to be like a gym for your brain. TooTallToby.com, practice models. It should be like a gym for your brain. So if your brain feels fried this time and you go back and do it again, you're going to feel a lot stronger. And then when you run into something like this at the the office, you're going to be ready to go, ready to handle it. So let's say this is our first sketch. We're going to go to revolve. So in Onshape, what I do here is I've got this whole sketch. I've got this center line that I'm going to revolve about. So I just click revolve, and then I just press tab. And what tab will do is it'll advance me from this box down to this box. So I use the tab key as a shortcut there for that workflow. So tab, now I'm in revolve axis. Now I can just click on this line down here, my center line, and then I can just press enter. Boom, there's that revolved shape, and that's kind of the main shape of the wheel. So I think this thing is looking good, and if you think it's looking good as well, be sure to hit the like button on this video. And let's now move on. So I'm going to press Shift 7, which is my shortcut for isometric, and that way I can kind of see which plane is cutting down through the middle here, and it looks to be my right plane. So I'm going to pick that right plane, S key, begin a sketch. And now I'm in sketch mode here on the right plane. And now I'm going to use a really cool command in Onshape called intersection curve. Now, what intersection curve or intersection does is it lets us grab the intersection of the right plane, which we're sketching on, and this face here, which is a cone. So it's going to let us grab the intersection of that and turn it into a line. It's going to let us grab the intersection of the right plane and this face here, which is planar. So we're going to have a line that comes across here. It's going to let us grab the intersection of this face here, which is a cone, and the right plane. So it's going to let us create a line here like so. And I'm just going to grab a few other lines. And the reason I'm doing this is because I think it just really makes it easy for you to visualize what's going on through that section of the model. So I'm sketching here on the right plane. I'm going to fly out this menu here that says use, and I'm going to choose intersection, and then I'm going to start picking these faces. So this face here, well, wherever that face is intersecting the right plane, we see that lines have been created. This face here, wherever that face is intersecting the right plane, lines have been created in my sketch. And this face here, and this face here, and maybe even this face here. And so that really makes it easy for you to quickly get it's almost reference geometry that you're going to need to create this rib shape, or that's going to help you to create this rib shape. Because now to create the rib, all we need to do is choose the 3-point arc command. So I'm going to exit the intersection command. I'm going to choose the 3-point arc command. I'm going to draw an arc that goes from here to here. So a little arc there between those two. And then I'm going to give that arc the radius of 220. 220, enter. And now what do I need to do? All I need to do now is just add in my dimensions. So I'm going to press the S key, go to dimension. I'm going to create a dimension here that goes from this line to this point. And that dimension is going to be at 5, enter. And whoops, let's hit escape. Let's get this point down below here. S key, dimension from this line down to this point. And that's going to be a dimension of 8. And boom, we are done with that sketch. That's the sketch for the rib. Now, I know that there's a lot of extra geometry here. Do we have to go through and delete that? No, not at all. Not in Onshape. We can just exit the sketch, choose the rib command. So here's the rib command in Onshape, rib up at the top there. And then once we choose that rib command, we can choose our sketch profiles, which is just going to be this arc here. We can then choose this second box here. I noticed that it really helps if you choose this second box here, parts, and then just click this part here. And so if you're not getting your rib preview, that may be what you need to do. That may be the extra step. Just make sure that you click in that second box and click this part. And then you've got the option here, parallel to sketch plane or normal to sketch plane. So you see normal to sketch plane, it's going a little bit crazy, and parallel to sketch plane, it actually works this time. And basically what that means is that when we sketched on the right plane. The right plane is running through the model like this. So the rib is also going to be running through the model like this. So it's just going to run parallel to the sketch plane as opposed to normal to the sketch plane, which would be like 90 degrees from the sketch plane. Sometimes that's what we want, but not in this example. So we're going to change that thickness there to, let's see here. We're going to change the thickness to 16 millimeters, enter. And there we go. There is our rib. We're also going to use this option here that says extend profiles to part. That will extend this little extra amount here. If that extra amount wasn't coming through, that'll extend that extra amount. And then we can hit the green check mark, and that creates our rib at 16 millimeters. Now, the one thing about this face here that really doesn't look that good is that we've got this face and this face and this face. We've got these kind of extra faces here. So is that really going to make that big a deal? It might not. You know, it depends on if you're using finite element analysis. It depends on if your machinists have a problem with having those extra faces. So if you do want to get rid of those faces, I think the best way to do that is to use delete face. So I'm going to choose delete face here. And when I choose delete face, I can choose this little, it's almost like a little dingus there, a little extra geometry that I wasn't anticipating. So I'm going to delete those two little faces and I'm going to say heal. And I hit the green check mark and oh yeah, that's what we wanted. Thumbs up in the chat, thumbs up in the video if you enjoy that usage of delete face. We always see those questions. Is there any way to get rid of these extra little faces? Well, a lot of times the way you get rid of them is with delete face. Yeah, delete face is absolutely epic. So now we're going to add draft manually or after the fact or after the feature. And we're going to do that by choosing this button right here, draft. So we choose draft and then we say neutral plane. Now what neutral plane is it's where the draft is originating from. And in the case of this rib, the draft is going to originate from that bottom face of the model. We saw some notes on that. And we also see that in the section view BB. So the draft is going to originate from the bottom face of the model or from this face here, the bottom of the pocket. So that is our neutral plane. And then for our entities to draft, we're going to choose this face and this face. And then finally, we're going to say that draft angle is supposed to be 6 degrees per side. So you would just type in 6 here, enter, and enter. And then we look at that rib. We look at the isometric view. Thumbs up. That looks pretty darn good. So that takes care of that feature. And now the final feature we need to create is the cut extrude on the back side of this and then the pattern. So we're going to roll around here to the back side. We're going to begin a sketch on this face here. S key, begin a sketch, N key to get normal 2. And we are going to create a sketch of a line. So we'll just, or sorry, of an arc. So we're just going to create a sketch of an arc here like so. And then we're going to hit escape. We will take this point of the arc and this point here at the origin and press I for coincidence. And then we are going to create a dimension there. So that dimension is going to be, so S key will create a dimension here. It's going to go from, actually, you know what? Let's create a dimension here let's create some angle dimensions here. So we'll create a line here as well. I'll use Q to make that a construction line. And I'll create a line here as well using Q to make that a construction line. Let's create some angle dimensions here. So we'll create an angle dimension here at 25. We'll create an angle dimension here at 25. And then once we have those angle dimensions, let's just turn that arc into a slot. So we go up here to the offset command. And when you fly out the offset command in Onshape, you can choose slot. So I'm going to choose slot here, and then I'm going to choose this arc, and then that slot distance is going to be that 40 dimension. So it's going to be the difference between radius 55 and radius 95. It's going to be the difference between these two dimensions here, this radius 55 at the bottom, and this radius 95, the radius down here and the radius down here, or up here. So we're going to create that at 40. So this dimension here is going to be 40, enter, enter. And then we can do a dimension for that lower arc, dimension for this lower arc here. And that dimension for that lower arc is going to be 55. And once you have those dimensions in place, that sketch should be fully constrained or fully defined. So again, if you want to pause the video, make sure that you've got that in the correct location if you're following along with the tutorial. And once we've got that, now we're ready to take this geometry and turn it into a cut extrude. So we once again choose extrude. So there we go. This is going to be a remove. So we're going to be removing that. This could probably go through all. The only reason I'm saying probably is because sometimes when you have a draft, the draft can end up cutting into this wall. So I'm going to say draft for this, and I'm going to say I want that draft to be, let's say we made it 20 degrees. Well, if that draft is at 20 degrees or more, maybe like if it was at 40 degrees, yeah, see here, it could end up cutting into this wall here. But I think with a very small draft, like 6 degrees, we're not going to have that problem. We got plenty of clearance there. So 6 degrees draft, that's going to give us 6 degrees per side. And we hit the green check mark. And boom, there is our slot with draft. So, you know, pick on that feature in the tree, Shift N for rename. And you could call that something like slot with draft. And maybe this one up here that we did earlier, the rib, click on that rib, Shift N for rename. This could be called rib with no draft. So that I know, you know, that some of the features have draft included in them. Some of them do not have draft included in them. So now in Onshape, we're going to finish this off by going into this flyout menu here. We're going to say circular pattern. And you want to remember in Onshape that you have to fly out this menu here and choose feature pattern. So circular pattern, feature pattern, and the features that I'm going to pattern, well, because I renamed them, it's pretty easy to find them here in the tree. Rib with no draft, and then the next feature, delete face, draft, slot with draft. There we go. And then the axis of the pattern, I'll just choose a circular edge. I'll choose this one here at the OD. And then the number of instances here is going to be 3, enter. And look at that. That pattern's looking good in the preview. So I'm going to hit enter again or hit the green check mark. And there we go. There is the model. We do what we call the final spin. Kind of look at this thing all around, make sure it looks like the drawing. I think that looks pretty good. And so now I'm going to go down here to the name of the part at the bottom. I'm going to right click and I'm going to say assign material. And this material here is going to come from the Too Tall Toby library. I've got a video on this on how to set up the Too Tall Toby materials library. So I'll be sure to include a link to that video here in this tutorial. But we're going to say that material is going to be ABS and hit the green check mark. And then I'm going to come down here to this corner and I'm going to choose this little mass properties button, mass properties, and I'll click on this wheel anywhere on the wheel. And I'm coming up with a mass here of 943 grams. So now I'm going to come back over here into the app and I'm going to type in that answer 943, enter, and oh yeah, we did it. Yes, we did it. We got it correct. Always feels good to get that purple box. And we see here that our time of 22:29 will be submitted and I'll be awarded 1 point on the community scoreboard. So I'm going to say submit, and yes, we did it. We got that answer correct. And so that is your Onshape Live Solve tutorial. If you enjoyed that tutorial, be sure to hit the like button on this video. Be sure to leave me a comment down below. But now we're going to turn back to our live stream, this episode of Model Monday Live, which we're live streaming here. And we see that while I was doing that tutorial, 9 people completed that challenge. That is awesome. And so if we go in here and we look at our first 42, we can see that the very first person to finish that one was none other than Rambro's Workshop, our current world champion of 3D CAD speed modeling using Fusion, and did it in just 7 minutes and 22 seconds from the time that the model was released. So it took me 22 minutes. It took Rambro's a mere 7 minutes and 22 seconds. That is super impressive. Followed quickly by Victor K using Onshape, 8 minutes 46 seconds. Followed by MCGA, 11 minutes 35 seconds. By Jackie coming in with 12 minutes and 7 seconds from Hong Kong. We see Dom here did it in 12 minutes 39 seconds.